Good evening, everyone. Good evening, everyone. Come on, join, my dear students. Okay. Welcome, my dear students, on the behalf of our reputed platform Unacademy, my dear students. Okay, today's session is a very important session. Before going for the today's session, let me depict you about myself, my dear students. Myself is Dr. B.N. Rao, having nearly complete the 17 years of the teaching experience. Out of that, 10 plus years of the teaching experience, where I am teaching the various subjects at the gate and the other competitive examinations, my dear students. Okay, and comes into the pure, okay, the gate and the engineering services level competitive examination. I am going to teach you the subjects of communications, core instrumentation, electronic devices, and VLSI design, okay, as well as the departments of both electronics and communications and electronics and instrumentation is concerned, my dear students. Okay, and moreover, one more important thing itself is that say I am having the completely 17 years of experience. Out of the 10 plus years, I have moved all the locations across the India, covering the northern and southern parts of the India, my dear students. Okay, and as I told, as if you want to go for the Unacademy subscription, if you are going to use my code and you are going to get the 10% discount, my dear students, very important. Okay, discount. Okay, now we are going to see that what kind of, okay, so what kind of the subscriptions are there as far as our Unacademy platform is concerned. Let me depict you in a brief manner. Okay, there are two types of subscriptions, my dear students. One is iconic subscription, second one is plus subscription. Okay, in iconic subscription, a personal coach is dedicated for each and every student regarding his subject. He will explain the study, that is subject, in a detailed manner, starting from the basic level to the till end in a detailed manner. Okay, and here a detailed study planner is also there, my dear students. So in this detailed study planner, my dear students, the subject concerned of okay, regarding the gated engineering services, the detail regarding the all the subjects, the detailed study planner is there over here. Okay, and you are going to get the expert guidelines also, my dear students. Okay, expert guidelines when it comes into the iconic subscription over here. Here in the iconic subscription, in advanced, that is in engineering services level stage 2 also, okay, there are certain sort of advanced questions that we are going to be discussing over here, my dear students. Okay, good evening, Kavita. And when it comes into the plus subscription, my dear students, you can access the live classes over here, my dear students. And these live classes also in any of the particular, that is regional language. Okay, it will be, you can go for the seeing of the various classes. Okay, from the very top educators across the India. It will be Hindi plus English or simply English, or you can go for the various other languages also, my dear students. Okay, and here the test series. Okay, when it comes to the test series, we can practice the unlimited number of test series, my dear students, over here. Okay, so that when you are attempting this particular examination, your level of confidence is going to be increased, my dear students. Okay, and here also in plus subscription, the structured timetable is also there, my dear students. Okay, welcome Srinivas Rao, welcome Vasu once again. Good evening, everyone, on the behalf of Unacademy, okay, platform. And it comes into the fee structures for the plus subscription. I told you that for both the GATE and engineering services, the for 12 months, okay, the package itself is, my dear students, 22,500, my dear students. If you are going to use, okay, the discount, you can use my code BNR10. Similarly, for iconic subscription, the fee structure is for 12 months, it is little bit cost. So 40,500, you can use my code BNR10 and you are going to avail the discount, my dear students. Okay, this is about this particular subscription. Okay, so these are the two subscriptions that are available at our Unacademy platform is concerned, my dear students. Okay, now when it comes into the fee structure, so as a plus educator, I am going to give much more importance for the plus educator only. So you can use my code and get the 10% discount. You can pay the fee structure through EMI, or you can use the net banking, or you can go for any of the cards, my dear students, so that you can pay the fee structure. Okay, this is about our Unacademy, my dear students. Okay, now I am going to enter into the subject. Okay, before entering into the subject, what we have dealt in the last session already I have explained you. Okay, so we have finished in the last session, okay, certain problems. Okay, we have finished the practice problems, because we have completed what, my dear students? We have completed, my dear students, that is analog communications. Okay, now in the previous session we have completed about the practice problems on AM. It is also finished. Next, practice problems on AM is finished almost all. Okay, all these problems we have finished in the previous class, my dear students. Okay, now practice problems on SSB also finished. Practice problems on the DSB also finished, my dear students. Okay, now we are going for the practice problems on which, my dear students? We are going for the practicing of the problems, my dear students, on the FM. Okay, so FM practice problems are very very important. We are going to discuss about these things also in a detailed manner, my dear students. Okay, the first one is I told you. See the question, the first question in today's class, okay, which is the continuation of the earlier class, my dear students, very very important. Okay, as a modulation index of the FM signal. Okay, see, as a modulation index, if I am going to take it, the modulation index, my dear students, of the FM signal with a sinusoidal modulation, listen, every point is very very important. Okay, S. Srinivas, okay, is increased from 0 to 3. It is increased from 0 3, the power in the carrier component. Okay, the power in the carrier component he has given, my dear students. Okay, so how it will be, so see how it is going to be, I am going to explain you in a detailed manner, my dear students. Okay, now first question is options. He has given the 4 options. Option A, increases continuously. Option B, okay, this is the second one, decreases continuously. Option C, okay, first increase, okay, first increase, then decrease. He has given this one. And option D, he only given that the fourth option is that first decrease, becomes 0. First decrease becomes 0. Okay, and increase, my dear students. Okay, first option is increase continuously, decrease continuously, first increase, okay, and attains a maximum value and then decrease. Fourth option, first decrease, then becomes 0, then increases. Okay, then increases. I am going to tell you here. Okay, now listen carefully, my dear students. The option is first decreases, okay, becomes 0, then increase. I will show you practically, my dear students. Okay, the answer itself is for this question is first it will be decreases, then, okay, first decreases, my dear students, then becomes 0 and increases. Okay, I will show you here. Okay, now see here, as the modulation index of the FM signal of sinusoidal modulation is increased from 0 to 3, means the modulation index is increasing from 0 to 3. 0 to 3. My dear students, what kind of FM it is? It is NBFM or WBFM? Is that NBFM or WBFM? So it is increasing from 0 to 3. So it is beta value is much greater than 1 only. So it is what, my dear students? WBFM only. WBFM. Okay. The power in the carrier component is asking. Okay. The power in the carrier component is asking. Okay. First, for what values? See, when the question will be given like this, see, the power in the carrier component is becoming. Okay. Always depends on which modulation index. Okay, the power in the carrier component depends on which modulation, always which Bessel coefficient term, always depends on what, my dear students? It depends on the carrier component, that is what? J naught of beta. Always the amplitude is depending on this one, J naught of beta. Okay, now for what values of beta? See, J naught of beta is becoming 0. First we have to take it that one. Okay, listen carefully. Now see here, my dear students. Okay, now here like this it is going on. For what values of beta? J naught of beta is becoming 0. This is, my dear students. J naught of beta, this is beta. For what values? The values are 2.4, this is 2.4. Next is what, my dear students? 5.5. This is already we have done 8.6. All these things we have done, my dear students, in the previous session. Okay, now this is J naught of beta. So here the J naught of beta is becoming 0 for what values? So the J naught of beta is becoming 0 when beta equal to 2.4, 5.5, 8.6, 11.8, etc. my dear students. Okay, very good, Srinivas. Okay, very good. Okay, for these particular values. Okay, now what I am going to do, first he is asking power. Okay, so what is the formula for power, my dear students? The power of the carrier, is equal to AC square into J naught of square beta by 2R. This is the formula for the power, my dear students. This is the formula for the power. Okay, now listen carefully. Here I am going to take it the function. See, listen carefully, my dear students. Here now see, this is J naught of beta. Okay, this is J naught of beta, my dear students, but power contains square term of J naught of beta. Power contains the square term of J naught of beta. So it is what? J naught square of beta. J naught square of beta. Okay, so he is asking the modulation index is increased from 0 to 3. Now it is increasing. Somewhere he is asking here. Okay, first up to 2.4. Up to 2.4, what is happening? It is decreasing only. 2.4 is, but in between 0 to 3 is asking. Okay, somewhere he is asking here. Somewhere he is asking 3 here. Okay, so 3 means this by squaring it becomes positive, because J naught square of beta is asking in power. The power contains the square term. The power contains the square term, my dear students. So ultimately what happens, my dear students? Slow, when comes into the 3, it increases. It increases means see, the power means the power in the carrier component first decreases, then it becomes 0, Now it is slowly increases, my dear students. Okay, is that clear over here? Is that clear? Okay. Okay, like that the question will be asked, my dear students. Okay, this is about the power of the carrier component. Okay, once again you have to remember in WBFM, okay, the power and on all the side bands depends upon their particular Bessel function J n out of beta. But the power, see, always the amplitude of the carrier component is also depending on J naught of beta. Okay, like already once again you revise all the, okay, the spectrum things regarding WBFM is concerned, because we are going to solve the problems now. Is that clear? Okay, next, this is about this particular problem, my dear students. So answer is first decreases, then becomes 0 and increases. Okay, and increases. Okay, it is crystal clear. Okay, now I am going for the next problem. Now in a FM system, a carrier of, okay, so I am going to take it a FM system. A carrier of 100 megahertz, okay, is modulated by a sinusoidal signal of 5 kilohertz. The bandwidth by the Carson's approximation is 1 megahertz. Okay, by Carson's approximation is 1 megahertz. 1 megahertz, my dear students, and he has given that waveform if y of t, okay, y of t is equal to modulated waveform cube, my dear students. Then by using the Carson's approximation, again, then by using Carson's approximation, you get, then by using the Carson's approximation, okay, now the bandwidth of y of t around 300 megahertz. The bandwidth of the y of t around 300 megahertz, my dear students. 300 megahertz. He has given the 4 options. One is, okay, 2.6 megahertz. Option B, 2.98 megahertz. Option C is 3 megahertz. Option D, 3.98 megahertz. He has given the 4 options. Is that clear, everyone? Everyone is following? Kavita, Vasu, okay, Srinivas Rao, everyone is following the? Listen carefully, my dear students. Okay, now he has taken the waveform generally. He is asking the Carson's rule. Okay, Carson's rule also, he has taken the waveform, and that particular waveform is y of t. Generally, what is the modulated waveform? S of t. Okay, so what is the general S of t waveform? S of t equal to AC into cos of, okay, 2 pi into fc into t plus beta into sine 2 pi into fm into t. This is a modulated waveform. This is nothing but, here I am going to take it, this one is nothing but S of t. ఇది నా వాడు ఇచ్చింది. ఫస్ట్ మీరు తెలుసుకోవాలి, అంటే ఈ టర్మ్ని నేను ఏం చేస్తున్నాను అంటే ఈ కంప్లీట్ టర్మ్ అనమాట. ఓకే, సో ఈ కంప్లీట్ టర్మ్ని నేను ఏం చేస్తున్నాను, నా y of t ఈక్వల్ టు so that is S of t term. S of t term is AC cos of 2 pi into fc into t plus beta sine 2 pi into Fm into T. This is cube. Okay, my dear students. As per, I told you, as per the WBFM, okay, as per the Armstrong method, okay, it is increases, the carrier frequency increases by 3 Fc, and bandwidth, because it is cubing, so the modulation index also increases by 3 beta, my dear students. Okay, you got my point. So this is very very important. This expression you are getting like this: y of t equal to AC into cos of 2 pi into 3 into Fc into t plus 3 beta into sine of 2 pi into Fm into t. This you are getting. And message frequency remains same. The message frequency remains same as per the Armstrong method. Okay, now here what he has given. Okay, now listen here. He has given the parameters like this. First one, here he only given, okay, he only given the value. Okay, first one is Fm is equal to 5 kilohertz. Yes, go for the previous one. Fm, how much he has given? See here, 5 kilohertz, carrier frequency is 100 megahertz. Okay, it will be given as a 100 megahertz. Okay, my dear students. Now, what I am going? I am writing that Fc equal to 100 megahertz. 100 megahertz, my dear students. Okay, now here what I am going to do? First, calculate the bandwidth. Okay, calculate the bandwidth, because it is what Carson's rule. Carson's formula. What is the Carson's formula for the bandwidth? Bandwidth equal to 2 into beta plus 1 into Fm, my dear students. Okay, he only given that. See here, the bandwidth at the initial stage he has given. See here, the bandwidth by Carson's approximation is how much? 1 megahertz. He only given at the initial. Okay, now the bandwidth as per the this how much he has given? 1 megahertz. Therefore 1 megahertz is how much? 1000 kilohertz, which is equal to 2 into, okay, 2 into beta plus 1 into Fm is how much? 5. Okay, so I am going to take it this one. Okay, this is how much? 5k. Okay, this is what, my dear students, k and k gets cancelled out. Therefore beta value you are getting, my dear students, how much? Because this is 5, here we are going to take it this one. Okay, so how much, my dear students, you are getting? 2 into beta plus 1 into 5k equal to 1000k. Okay, so this value is 1 megahertz. 1 megahertz there, right, my dear students. So what is the value you are getting, my dear students? How much you are getting? How much you are getting? These 10. See here, what is the value of beta? How much you are getting beta value? Beta ఎంత వస్తుందని ఇక్కడ? What is the value of beta? 99 వస్తుంది. ఓకే, నౌ ఇప్పుడు వాడు ఏమంటున్నాడు? నెక్స్ట్ థింగ్, he is saying that the bandwidth y of t at 300 megahertz. ఓకే, ఎఫ్సి అంటే వాడు అడిగేది ఏంది? 300 మెగాహెర్ట్జ్. అంటే మీకు ఎఫ్సి అనేది 100 కాస్త ఏమవుతుంది? ఎఫ్సి అనేది మనకి ఈ ఈజ్ ఆస్కింగ్ ఎట్ 3 times ఇంక్రీజ్ అయింది, అంటే 300 మెగాహెర్ట్జ్. అర్థమైందా? ఈజ్ ఆస్కింగ్ ద బ్యాండ్ విడ్త్. వాట్ ఈజ్ ఆస్కింగ్? 300. అంటే అప్పుడు బీటా వాల్యూ ఎంత అయింది? బీటా ఆల్సో ఇంక్రీజెస్ బై 3 times ఆఫ్ బీటా. is asking that only na. Therefore bandwidth equal to 2 into beta plus 1, that is what is beta? 3 into beta. Very good. 99, not 9, not 9 Srinivasarao, 99. 2 into 2 into 3 beta, okay, plus 1 into FM. Okay, therefore it is equal to 2 into 3 beta, means 3 into 99, okay, not 9 Srinivas, 99, very good, 93 into 99, 3 beta, okay, plus 1 into FM, message frequency remains same, it is 5K. Now what is the answer? Tell me the answer, my dear students. Kavita, answer cheppamma. Kavita, Vasu, what is the answer? What is the answer? Very good. Very good, Srinivas Rao. So what is the answer, my dear students? 2 point ఎంత వచ్చిందనా? 2.98, okay, megahertz. Very good, Srinivas Rao. Convert the answer in megahertz. That is very, very important over here. Okay. Now, this is about this particular problem, my dear students. Okay. So, you are getting the answer. This term I am writing here. You are using this one. Okay. Again, this value I am writing here. The bandwidth equal to, because it is gone at my back side. What, my dear students? ఏం చేస్తున్నారా? Bandwidth equal to 2 into 3 into 99 plus 1 into 5K. You are getting 2.98 megahertz. Very good. Very good. Kavita, Vasu, are you there? Okay. Chalo. With that, we had completed this question. Is that clear, everyone? I am going for the next one. Next problem, my dear students. Okay. Now listen. This is again one more practice problem on FM. An FM signal is generated, my dear students, using the single tone sinusoidal frequency, that is single tone sinusoidal signal of frequency. He only given, my dear students, the frequency is very, very important over here. The frequency FM, okay, and the here the modulation index also he has given, that is beta, it is 6, he only given, and the fraction of the total frequency contained in the range of, okay, in the range of FC minus 4 FM to FC plus 4 FM, my dear students. Okay, the question he has given like this. Okay, he has given the other parameters also in very, very, okay, he has given the terms. Now listen here. He has taken the FM signal is generated using, say, there is sinusoidal signal of frequency FM and a modulation index is 6. Modulation index is 6 means, my dear students, this is what WBFM. This is what WBFM, and the fraction of the frequency contained in the range of. So we have to go for what? We need to go for the what, my dear students? We need to go for the spectrum of WBFM. Okay, and he has given the values also like this. Values కూడా ఇచ్చాడు అలా, ఇలా ఇచ్చాడు వాడు ఇచ్చిన వాల్యూస్. ఓకే, దట్ ఈస్ J1 of 6 equal to 0.2767. That is J1, first J0 of 6 కూడా ఇచ్చాడు అలా, J0 of 6 equal to 0.1506. next J2 of 6, okay, it is equal to 0.2429. next J3 of 6, J3 of 6 ఇచ్చాడు అలా, how much it is 0.1506. and this is J3 of 6 is so already this is J3 of 6 is not this one. He has given the J3 of 6 is how much means 0.1148. okay, next he has given that J4 of 6 also, J4 of 6 he has given, this is also 0.3576, 3576 my dear students. ఓకే, ఈ వాల్యూస్ ఇచ్చినాడు అన్ని, అర్థమైందా? ఈ పారామీటర్స్ అన్ని ఇచ్చాడు. నౌ హీ ఈజ్ ఆస్కింగ్ వాడికి పవర్ కంటైన్డ్, వాడికి పవర్ కావాలంటున్నాడు. వాడికి ఎలా పవర్ కావాలంటున్నాడు చెప్తాను. ఇది బోత్ సైడ్స్, okay. Now see here, this is my dear students, he only given one side this చెప్తున్నా, FC plus FM, FC plus 2FM, FC plus 3FM. okay, we are going to take it up to 4 because he is asking up to 4 my dear students. ఇలా ఇది ఇచ్చాడు, దిస్ ఈస్ FC plus 4FM. okay, similarly FC minus FM, okay, FC, okay, minus 2FM, this is FC minus 3FM, this is FC minus 4FM. now my dear students, he is asking what is the total power. okay, he is asking the total power contained in the frequency range. okay, he is asking the complete power that is ranging from here to here my dear students. okay, he is asking the total power from here to up to here, means that is FC minus 4FM to FC plus 4FM. he is asking the power. okay, this is what my dear students, this is AC into J0 into beta by 2. This is AC into J1 into beta by 2. This is AC into J2 into beta by 2. This is AC into J3 into beta by 2. This is AC. okay, this I am going to take it here, AC into J4 into beta by 2 my dear students. okay, similarly for this one, this is for here, for this one. okay, similarly you are going for this one is over here, next one this one is over here my dear students, and this one is present, this one is presenting over here. Is that clear everyone? okay, now what is the total power he is asking in this band? okay, now the total power in the band of FC minus 4FM, okay, to FC plus 4FM, he is asking in this band the total power. Is that clear? Then it will be my dear students very important. see, FC, First, we have to write down the power for the FC. So, I am going to take it AC square by 2 are common. 2 are common. Only one is there. Only one J naught. Only one term is there. Therefore, it is J naught square into beta by. Okay. See, this is the, but beta value is how much here? He only given in the question. What is the value of beta? The modulation index is what is the value of beta, Srinivas? Everyone? What is the value of the beta, my dear students? Okay. The beta itself he only given how much? Beta equal to 6. Now going for this one. So here you have to take it this one out. This one out. And this is 6, my dear students, plus next one is 2 times, because here one is there, here one is there, 2 times, 2 into my dear students, two into J1 square of beta plus 2 into J2 square. What is that beta value again here? Again you have to substitute here same 6. Here 2 into J2 square of 6, 2 into J3 square of 6 plus like that we have to write down. Okay, plus 2 into J power 4 of 6 we have to write down like this, my dear students. Okay, now you have to add all these particular values. This is J0 of 6, J1, J2, drop this all these values, substitute here, substitute in this particular expression. Okay, when you are substituting all the values over here, my dear students, you need to substitute all these particular values. Okay, then you are getting the total power, my dear students, and the total power how much you are getting, that is very very important, and that total power you are getting is I am writing directly how much it is, 57.6%, my dear students. Okay, this is the value you are getting, my dear students. Okay, you are getting, this is the value 57.6 వస్తుంది. అర్థమైందా నాన్న? శ్రీనివాస్, వాసు, కవిత, is that clear here? How I have done the problem? Okay, now this is the problem that has been asked in the previous, all these questions has been asked in the previous gate papers only, my dear students. Is that clear everyone? Is that clear? Okay, next, is that clear everyone? Okay, now I am going for the next problem, my dear students. Very very important problem. Okay, now you are getting the values. See, always the spectrum, okay, of WBFM or the amplitude of all the spectral components depends on the Bessel function coefficient. What is that? J of beta. Okay, but when we are going to solve the problem, we will definitely give the all these particular values. Very very important. Okay, now I am going for the next problem. Now listen here, next question. The modulating signal into the FM modulator. Okay, the modulating signal into an FM modulator, he only given m of t equal to 10 cos. Okay, 10 cos 20 pi t. Okay, and the output of the FM modulator S of t equal to 10 cos 4000 pi t plus 2 pi into kf into integration of m of t into dt. He only given, my dear students. Okay, he only given all these parameters. Okay, and the output of the C, and he has given the value of kf also. Kf equal to 5 Hz per volt. 5 Hz per volt. The output of the FM modulator is passed through a, okay, is passed through a ideal band pass filter at a centered frequency FM, that is FC equal to 2000 Hz with a bandwidth of, this is very very important, my dear students, how much bandwidth we are going to use, that also he has given. How much it is? 80 Hz. Okay, he has given this particular bandwidth, my dear students. Okay, now here using all these particular parameters, all these particular values, now we are going to solve the problem, my dear students. Okay, and here also he has given certain values also. Okay, a values emi ichadante, listen here. He has given the values of Basils. He has given the values, my dear students. First one is J naught of 5 equal to minus 0.178. Okay, J naught of 5. J1 of 5 equal to minus 0.328. J2 of 5. All these values he has given. J2 of 5 equal to 0.047, and J3 of, okay, 5 equal to, first two are negative, next are all positive, 0.365. J4 of 5 equal to 0.391, and similarly he has given that J0 of 10 also. J0 of 10 equal to, he has given minus 0.246. Similarly J1 of 10 equal to, he has given, this is 0.043. J2 of 10 equal to, my dear students, it is 0.255. J3 of 10 equal to, my dear students, which is equal to 0.058. Okay, and fourth one is J4 of 10, which is equal to, how much he has given? 0.22. All these values he has given, my dear students, like this. Okay, now these are the very very important. So using the Bessel values only we can solve the problem. మనం problem solve చేస్తాం, లేకపోతే కష్టం. Definitely we have to use all these particular values, my dear students. Okay, similarly now I am going for the usage of, because he is asking only in the bandwidth of 80 Hz only. Okay, in the bandwidth of 80 Hz means, first write down the parameters what he has given, my dear students. Okay, what is the value of all these particular values you have to write down. Okay, first we have to write down the parameters of the question. Okay, first one is the AM value, how much? 10 volts, and FM is equal to 10 kilohertz. 10 Hz, not 10 kilohertz only, 10, my dear students, it is 10 Hz. Heads, my dear students. Okay, and similarly he has given the AC value, how much? Equal to S of t is equal to, again this is also 10 volts only. Okay, now he has given the KF value, how much? KF equal to 5 Hz per volt. Okay, now first find out beta. Beta equal to del F by FM. But what is del F? KF into AM by FM, my dear students. Okay, similarly beta equal to del F. What is del F, my dear students? Del F equal to KF, means it is 5. Okay, into AM value is how much? 10 divided by, again it is 10, so we are getting beta is 5. So always we need to use the values of the beta of 5 only. We need to use only these values. You are going to use only the beta values. Okay, now he is asking only in the bandwidth of 80 hertz only. Okay, so what are the spectral components we need to take? Means he is asking, okay, in the bandwidth of 80 means take it. See, in the bandwidth of 80 he is asking, okay, FC plus FM1, FC plus FM, FC plus 2FM, FC plus 3FM, FC plus 4FM. This is minus FM. Next one is this. Next one is this, and next one is this, my dear students. Now he is asking, my dear students, only in the bandwidth of this is EFC plus 4FM, and this is final one is EFC minus 4FM. His question is he is asking the power, okay, the power in between the bandwidth of what, my dear students? Go for the question once. Bandwidth of what? 80 hertz. It is passing through that. Okay. So he now this is the first part. What the things he is asking, I am going to tell you one by one. Okay. The first one itself is in this particular bandwidth of 80 hertz. He is asking the power of the spectral components that is passing through this filter. After passing through the filter. Okay. So here, my dear students, this is okay only after passing through the filter, band pass filter. Okay, only the bandwidth should be how much? Only 80 you have to get. So this is EFC plus. So when you are getting 80, my dear students, you are getting 80. 80 ఎప్పుడు వస్తుందా? ఇక్కడ దీంట్లోంచి ఇది తీసేస్తే మీకు ఎంత వస్తుంది? 8 FM వస్తుంది. 8 FM అంటే which is nothing but ఎంత? 8 into each one is 10. 80 hertz. Okay. So ఈ complete spectral components very good ఉంటాయి. You are having the other spectral components also, my dear students. You are having the other spectral components also there. Okay, like this, some other components also there. Okay, like this it is there. But he is asking the only the passing to the band pass filter, but only the bandwidth should be of what, my dear students? Only the bandwidth is 80, my dear students. Only you need to get 80 hertz. So we need to add the values. We need to add the values from PFC to up to here. Up to here, my dear students. Okay, so we need to all these particular values up to here only, because the bandwidth is only 80. Okay, so the first question is the power of the frequency components output of the filter. Power of the frequency components at output of the filter. Okay, at the output of the filter, my dear students. Okay, now we have to write down all the terms. Okay, then output of the filter means that is passing to the filter. Okay, complete spectrum, my dear students, listen carefully. Complete spectrum, this is passing through like this. So many, like this it is there, like this. Okay, this side also so many it is there. Now it is passing through which where? It is passing through BPF filter having the bandwidth of 80 hertz. So it is the range is how much? PFC. Okay, so the components are PFC minus 4FM to PFC. P of EFC plus 4FM, my dear students. You are getting this only. Now the total power, my dear students, which is equal to, okay, the total power equal to again AC square by 2. AC square by 2, my dear students. Here beta value is how much? 5. So J0 square of 5 plus 2 into J1 square of 5 plus 2 into J2 square of 5 plus 2 into J3 square of 5. Okay, and similarly fourth one is plus 2 into J4 square of 5. My dear students, you need to go for all these particular values. Okay, now substitute all these particular parameters. ఈ అన్ని పారామీటర్స్ని మీరు ఇక్కడ వేసేయండి అన్న. J0, J1, J2, J3, J4 ఈ వాల్యూస్ అని సబ్స్టిట్యూట్ చేయండి. Substitute all these particular values, my dear students. Okay, then you are getting what is the answer? You are getting the value, my dear students, the total power. Okay, the total power is how much you are getting means that is 82.35 okay watts. You are getting this value. Okay, so here he is asking that this complete values this complete values, my dear students, you are getting this value is 41.17 watts. You are getting, my dear students. Okay, then the power of all these particular spectral components is this only, my dear students. Is that right? What are the value I have written over there? Is it right, my dear students? Is that right, my dear students? Is this value is right? No, because that's what I'm checking over here. Okay, the correct value is, my dear students, you are getting the value is 82.2 watts. 82.2 watts. Okay, that's I'm checking you whether you are following or not. I'm checking, my dear students, while doing the problems you should be in a position there you need to follow, my dear students. Okay, very very important. Okay, so you have to add all these particular values, then only you are going to get the answer. Okay, very very important, my dear students, over here. Okay, next, my dear students. Okay, everyone is following? Kavita, Vasu, Srinivas, everyone is following, my dear students? Everyone is following over here. Is that clear, everyone? Is that clear, everyone? Is that clear, everyone, over here? Okay, can I go for the next problem? Can I go for the next problem, my dear students? Everyone is following here. Okay, now students, he has given the question, a phase modulated signal evenly given in a time domain. He has given the phase modulated signal in a time domain s of t. S of t equal to, my dear students, AC into cos. Okay, cos of 2 pi into FC into t plus KP into AM. Okay, KP into AM into sin 2 pi into FM into t. My dear students, he has given this one. Okay, he is asking where Kp is what? Phase sensitivity of the modulator, you only given. Now what is the peak? Okay, peak frequency deviation is how much he is asking. Okay, what is the value of the peak frequency deviation? He has given the 4 options. First one is Kp into AM. Option B, he has given that Kp into AM by FM. Option C, he only given, my dear students, Kp into FM by AM. Option D, Kp into AM into FM, my dear students. This is he has given. Okay, he has given these values, my dear students. Okay, now he is asking what is the peak phase deviation is asking, my dear students. Okay, to go for this particular peak frequency, that is a frequency deviation, not phase deviation, sorry, it is a frequency deviation. What we have to do? Okay, So what is the formula, my dear students? As you know that beta, okay, so beta equal del f by fm, but beta equal to del f by fm, but what is del f? Del f equal to, okay, beta into fm, okay, but what is the term we can write down over here, okay, beta, okay, so beta can also be written as, so phase deviation we are representing in terms of beta is what, my dear students? Beta is nothing but same as phase deviation. So here del f equal to phase deviation into fm. And what is phase deviation? Phase deviation equal to kp into am. Therefore del f equal to kp into am into fm, my dear students. You are getting, my dear students? This is del f equal to kp into am into fm, my dear students. Is that clear? So option is what, my dear students? The option is D. The option is what, my dear students? The option is D, my dear students. Okay, that in that way we are going to solve the questions over here, my dear students. Okay, similarly, is that clear, everyone over here? Okay, can I go for the next problem over here? Okay, my dear students. Okay, is that clear? Okay, next question. Now, practice problems on FM. Another problem, my dear students. This is also important question. Let, he has given that S of t signal, my dear students. S of t will be a general angle, that is general modulated signal, my dear students, and given by S of t equal to AC into cos of theta it, my dear students. Okay, where which is equal to, he has given AC into cos of omega c into t plus phi into t, my dear students. He only given like this. Okay, he only given this one, and he has given the modulated signal m of t equal to cos, he has given this one, cos omega m into t, my dear students. Okay, then he has given the modulated signal, and S of t has a instantaneous frequency. For this, S of t has an instantaneous frequency, my dear students. That also he has given. Okay, given by, what is that? That value is how much? Fi of t. Okay, Fi of t equal to Fc. Okay, Fc plus 2 pi into k into Fm into whole square into cos into omega m into t, my dear students. Okay, where he has given that k is a constant. He only given that which one? The k is a constant. Okay, he has given all these particular parameters over here. Okay, now here k is there. This k is representing the constant, my dear students. Okay, now he has given the 4 options. ఇక్కడ 4 options ఇచ్చాడు. Okay, very very important. First option, 4 options ఇచ్చాడు, A, B and C and D. Okay, the first option is A. ఎంత ఇచ్చాడు? 2 pi into Fc into t plus k into cos of omega m into t. Next, 2 pi into Fc into t plus k into sin omega m into t. He has given this one. Okay, third one, 2 pi into Fc into T, my dear students. He has given the four options, okay, plus omega m, okay, into K into sine omega m into T, my dear students. Fourth one, 2 pi Fc into T minus omega m, okay, that is K into sine omega m into T. He has given the four options, my dear students, like this. Okay, now we need to find out the instantaneous frequency. We have to find out what, my dear students, the instantaneous frequency, my dear students. It is very very important over here. Okay, so we need to find out that particular value also, very very important over here. Okay, now how to find out the instantaneous frequency? ఎలా ఫైండ్ అవుట్ చేస్తారా ఇన్స్టాంటేనియస్ ఫ్రీక్వెన్సీని? వెరీ వెరీ ఇంపార్టెంట్ మై డియర్ స్టూడెంట్స్. ఎలా ఫైండ్ అవుట్ చేస్తారు? వాడే ఇచ్చాడు కదా, ఎంత ఇచ్చాడు? ఎఫ్ఐ ఆఫ్ టీ. ఓకే, అది రాసుకున్నాను ఫస్ట్. యు ఆర్ రైటింగ్ ద వాల్యూ. ఎఫ్ఐ ఆఫ్ టీ ఈక్వల్ టు ఎఫ్సి ప్లస్, మై డియర్ స్టూడెంట్స్, 2 pi into K, okay, he has given into Fm square, he has given this one into cos omega m into T, my dear students. He only given this term. Okay, now keep these terms aside. My dear students. Now first we need to write down the instantaneous frequency formula. What is the formula for the instantaneous frequency? The formula for the instantaneous frequency, Fi equal to 1 by 2 pi into d by dt of, this is the formula. Already I told you in frequency modulation. Okay, now from this particular one, so we have to do the integration on both sides. Okay, so here I am going to do the integration on both sides. On both sides I have done the integration, my dear students. Then what happens? The term will be, this becomes integration, differentiation gets cancelled out here. Then it becomes theta of t. Theta of t equal to, my dear students, 2 pi into integration of Fi into dt, my dear students. Fi into dt, my dear students. Very very important over here. Okay, and now this particular one you have to substitute this one. Now substitute here. Okay, therefore theta of t equal to 2 pi into integration. Okay, integration of Fc plus 2 pi into K into Fm into square into cos omega m into T, my dear students. Okay, into with respect to dt, with respect to dt. Then what happens to the theta of t value? Theta of t equal to 2 pi Fc into 1 dt. It is nothing but 2 pi into Fc into T. Okay, next again multiplying by 2 pi, and here 2 pi is there. K into Fm square is already, it is there, and integration of cos, it becomes what? Sine. Okay, sine omega m into T divided by what? Omega m. What is omega m? 2 pi into Fm, my dear students. Omega m is. Okay, is that clear over here? Okay, now what happens? This 2 pi and these 2 pi gets cancelled out. This square, this cancelled out by one time, my dear students. Therefore theta of t equal to 2 pi into Fc into T, my dear students. Okay, plus what I am taking? I am taking the 2 pi and K. K is there. K write down here. K write down here, my dear students. And it is 2 pi into Fm. 2 pi into Fm is what? Omega m into sine omega m into T, my dear students. So what is the answer? The answer is the option C. The option is what, my dear students? The option itself is C, my dear students. This is the option where you are getting the answer. You are getting the answer, my dear students. That way we are going to solve, okay, the problems over here in a detailed manner. Okay, everyone is clear over here? Everyone is clear over here, my dear students? Can I go for the next problem? Can I go for the next problem? Okay. Your chart is not getting VC value how much, sir? Wait. Now I am getting your chat. Sai Pavan, good evening. Srinivas, what is your question? Vasu, AC value is how to get it, sir? Where? Yes. Sorry, I am not getting chat. Now only I got the chat. Is that clear up to here, everyone? Srinivas, Vasu, Kavita, Saidesh. Sorry for that, I am not getting the chat over here. Any doubt in this question? Any doubt in this question? Any doubt here? In this question? Kavita, Saidesh, Srinivas, Vasu. చెప్పండి అన్న. Previous problem, what happened? Tell me. Previous problem, what happened, Srinivas? Tell me once. No doubt. What is the problem in C? Ask Srinivas, no problem. Now I am getting your chart. ఇప్పుడే నాకు మీ చార్ట్ కనబడుతుంది. ఇంతసేపు చార్ట్ కనబడలేదు మీది. ఓకే, కంటిన్యూ చేస్తా. కవిత, మీకు ఏం డౌట్స్ ఉంటే అడగండి, ఏం కాదు. ఒక నిమిషం అడగండి, నేను ముందుకు వెళ్తాలేండి. ప్రీవియస్ ప్రాబ్లంలో ఏమైనా డౌట్ ఉందా? Any doubt? Yeah. How to find AC? AC, he has given, Srinivas, 57.6. The problem is once. See here. In this particular problem, he has given the AC value also, Srinivas. See here, beta equal to 6. He only given. Okay, very good question, Srinivas. Okay, he has given that AC value. He has given that AC value. Wait, my dear students. The fraction of total power contained in the frequency range of. Good question, Srinivas. Contained in the frequency, in the fraction of. Okay, Srinivas, listen carefully here. Listen carefully, my dear students. His question is, see in this question, the fraction, see here, this 57.6, how much you are getting? If 57 points ఎలా వచ్చింది మీకు? Divided by, see, this formula is this one. This is the formula. Here the fraction is asking. The fraction means he is asking the fraction of the total frequency spectrum contained in the range of, means he is asking the power in terms of. Yes, good question. Wait. Here I forgot to tell that. Okay, P equal to the total power, means the total of all the powers divided by PC. Okay, in this one here what happens? This multiplied, this completely multiplied by here. This completely multiplied by here, my dear students. Multiplied by again AC square by 2R. He is asking this one. He is asking this gets cancelled out. He is asking the ratio of the all the powers divided by the carrier power. Now Srinivas, your doubt is clear? Yeah, Srinivas, now I think your doubt is clear. Okay, now he is asking that the fraction of the total power contained in the frequency range of. Okay, he is asking the ratio of the total of all the powers divided by my dear students by the carrier power. Okay, now you are getting, my dear students. Okay, now this problem is clear. This problem is clear, everyone. Okay, now this problem is clear. This problem is clear, my dear students. This is also clear. Okay, so what is the integration? Okay, the integration of cos omega t is how much? Integration of cos theta, or simply integration of cos theta is what? Okay, up to here everyone is clear? Okay, chalo, I am going for the next one. Okay, now sorry for that my boys, నేను కొద్దిగా ఈ చార్ట్ని చూడలేదండి, చార్ట్ ఇప్పుడే వచ్చింది నాకు, ఆన్ అయింది. ఓకే ఫర్ దట్. ఓకే, నౌ నెక్స్ట్ క్వశ్చన్. ఇలా నాన్న క్వశ్చన్స్ మీకు ఇస్తాడు, డిఫరెంట్గా ఇస్తాడు. ఓకే, నౌ మనకి నెక్స్ట్ ఇక్కడ దాకా ఏమైనా డౌట్స్ ఉంటే నాకు టెలిగ్రామ్లో కూడా పంపించండి. ఓకే, వెరీ గుడ్ కవిత, నౌ వీఆర్ ఫాలోయింగ్ ఓవర్ హియర్. నెక్స్ట్ ఇప్పుడు నేను ఏం చేస్తానంటే ఇంకో ప్రాబ్లం చేస్తాను. ఇది చాలా ఇంపార్టెంట్. ఇవన్నీ మీకు ఇంతకుముందు బయట అడిగిన ప్రాబ్లమ్స్ ఏనా, చాలా జాగ్రత్తగా చేసుకోవాలి ఈ ప్రాబ్లమ్స్ అనేవి మనము. ఓకే, వెరీ ఇంపార్టెంట్. ఓకే, ఇప్పుడు ఒక మెసేజ్ సిగ్నల్ ఇచ్చాడు అలా. ఓకే, యాజ్ in the following figure, a message signal is given, m of t, signal m of t is given in the figure. Means ఆ ఫిగర్ లో ఇచ్చిన దానికి ఏం చేస్తాడంటే ఈజ్ ఫేజ్ మాడ్యులేటింగ్ ఏ క్యారియర్, ఈజ్ ఫేజ్ మాడ్యులేటింగ్ ఏ క్యారియర్, is phase modulating a carrier of 1 megahertz with a phase sensitivity of pi radian per volt, పై రేడియన్ పర్ వోల్ట్, మై డియర్ స్టూడెంట్స్. ఇది ఇచ్చాడు అన్నమాట. ఓకే, అప్పుడు డయాగ్రామ్ ఏమి ఇచ్చాడంటే వెరీ ఇంపార్టెంట్, చాలాసార్లు ఇలాంటి క్వశ్చన్స్ అడుగుతూ ఉంటాం మీకు ఎగ్జామ్స్లో. ఇలా ఇచ్చాడు. ఇలా క్వశ్చన్ ఇచ్చాడు అలా. నా this is here, very good. It's now m of t, ఇది వోల్ట్స్ లో ఇచ్చాడు అలా. ఓకే, ఇక్కడ ఇది 0, ఇక్కడ ఇది 1, ఇది 3, ఇక్కడ వీడు ఇచ్చాడు ఇది 4. ఓకే, ఇది మ్యాక్సిమం ఏమో 10 power 5. ఓకే, మ్యాక్సిమం ఈజ్ 10 power 5 ఇచ్చాడు అలా. అక్కడ క్యారియర్ వాల్యూ ఇచ్చాడు ఇక్కడ 1 megahertz. he has given this particular value 1 megahertz ఇచ్చాడు, and sensitivity is pi radian per volt వాడే ఇచ్చాడు. ఓకే, he only given all these values. Okay, now he is asking the maximum and minimum instantaneous frequencies of the modulated signal. Okay, he is asking what the maximum and minimum instantaneous frequencies, my dear students. He is asking maximum and minimum instantaneous frequencies, my dear students. He is asking. Okay, very important, my dear students. Okay, and he has given that fc is how much? ఎఫ్సి ఈక్వల్ టు 1 మెగాహెర్ట్జ్ ఇచ్చాడు అన్న. అండ్ ఫేజ్ సెన్సిటివిటీ ఇచ్చాడు. అదేంటి ఇచ్చాడు? కేపీ ఈక్వల్ టు పై రేడియన్ పర్ వోల్ట్ అతనే ఇచ్చాడు. ఓకే, నౌ ద మ్యాక్సిమం అండ్ మినిమం మీకు తెలిసిందే కదా ఫార్ములా. విత్ రెస్పెక్ట్ టు ద మ్యాక్సిమం అండ్ మినిమం చేయాలంటే ఎలా అనేది. ఓకే, సో దీనికి మ్యాక్సిమం అండ్ మినిమం ఇన్ టర్మ్స్ ఆఫ్ ద ఫార్ములా, ఫస్ట్ ఫార్ములా అయింది, జనరల్ ఫార్ములా అయింది నాన్న. కేపీలో ఎఫ్ఐ ఈక్వల్ టు ఎఫ్సి ప్లస్ కేపీ బై 2π ఇంటూ డి బై డిటి ఆఫ్ ఎమ్ ఆఫ్ టీ. మై డియర్ స్టూడెంట్స్, వెరీ గుడ్ శ్రీనివాస్. ఓకే, 1 మెగాహెర్ట్జ్. ఓకే, ఇది మామూలుగా మన ఫార్ములా. ఓకే, ఇదే దానికి మ్యాక్సిమం అండ్ మినిమం అంటే ఈ యొక్క డయాగ్రామ్కి మనకి ఎలా వస్తుందనంటే మై డియర్ స్టూడెంట్స్ ఇలా వస్తుంది. ఓకే, యు ఆర్ గెటింగ్ మ్యాక్సిమం మినిమం నేను చేస్తున్నాను, మ్యాక్సిమం ఫ్రీక్వెన్సీ అండ్ మినిమం ఫ్రీక్వెన్సీ ఇలా. అర్థమైందా నాన్న? దీనికి యు ఆర్ గెటింగ్ ద వాల్యూస్. ఇక్కడికి వచ్చేసరికి ఇది మ్యాక్సిమం వచ్చేసరికి ఇది ఎంత 10⁵ అవుతుందనా. ఇది వచ్చేసరికి ఇది ఎంత అవుతుంది? దిస్ ఈజ్ మినిమం అంటే అదే కదా, మినిమం అంటే మైనస్, మినిమం విల్ బి మైనస్ మై డియర్ స్టూడెంట్స్. ఓకే, మినిమం ఇది మ్యాక్సిమం అయితే ద మినిమం ఇన్స్టాంటేనియస్ ఫ్రీక్వెన్సీ ఎంత ఉంటుంది? ద 10⁻⁻5 దగ్గరే ఉంటుంది. అది బై డిఫాల్ట్ మీకు తెలిసిందే. ఓకే, మనం అంత పారామీటర్స్ చేయాల్సిన అవసరం లేదు. ఇది 0, ఇది 1 మై డియర్ స్టూడెంట్స్, లైక్ దట్ ఇట్ ఈస్ 3 and 4 లైక్ దట్ ఇట్ ఈస్ దేర్. ఓకే, సో ఇక్కడ ఎఫ్ఐ ఆఫ్ మ్యాక్స్ ఈక్వల్ టు ఎఫ్సి ఓకే ప్లస్ కేపీ బై 2π ఇంటూ డి బై డిటి ఆఫ్ ఎమ్ ఆఫ్ టీ ఆఫ్ మ్యాక్స్ మై డియర్ స్టూడెంట్స్. ఓకే, నౌ సబ్స్టిట్యూట్ చేయండి. ఎఫ్సి వాల్యూ ఎంత? 1m. కేపీ వాల్యూ ఎంత? పై 2π పోతే ఎంత ఉంటుంది? 1/2. ఓకే, అండ్ హియర్ 10⁵ కెన్ బి రిటన్ యాజ్ 10⁵ ఏం తీసుకుంటున్నాను నేను? 10⁵ ఈస్ 100k. ఐ కెన్ రైట్ వాజ్ ఏ 100k. చెప్పండి అన్న ఎంత వచ్చింది వాల్యూ ఇక్కడ? ఎఫ్ఐ మ్యాక్స్ వాల్యూ ఎంత? టెల్ మీ మై డియర్ స్టూడెంట్స్ ఇన్ కిలో హెర్ట్స్లో చెప్పండి. ఎఫ్ఐ మ్యాక్స్ వాల్యూ టెల్ మీ ఇన్ కిలో హెర్ట్స్. ఎఫ్ఐ మ్యాక్స్ వాల్యూ ఎంత అన్నా? కిలో హెర్ట్స్లో చెప్పండి. ఎఫ్ఐ మిన్ వాల్యూ ఆల్సో చెప్పండి. యా, వాట్ ఈస్ ద కంప్లీట్ వాల్యూ? ఈ కంప్లీట్ వాల్యూ ఎంత? దిస్ ఈజ్ మెగా శ్రీనివాస్, మెగాలో ఉంది ఈడ. టెల్ మీ ఇన్ కిలో హెర్ట్స్. కవిత మెగాలో ఉందమ్మా ఈడ. దిస్ కెన్ బి రిటన్ యాజ్ కిలో హెర్ట్స్లో చెప్పండి. 1000k ప్లస్ దిస్ ఈజ్ హౌ మచ్? 50k. Yes, very good. 1050k శ్రీనివాస్, 1050k. ఇప్పుడు కరెక్ట్ వచ్చారు. కవిత చెక్ చేసుకోమ్మా, తప్పు వచ్చింది ఆన్సర్. సిమిలర్లీ మినిమం ఇది చెప్పండి. వెరీ గుడ్ శ్రీనివాస్, వెరీ గుడ్. కవిత ఫాస్ట్ ఉండాలమ్మా. ఓకే, దిస్ ఐఎమ్ గోయింగ్ టు గెట్ ప్లస్ బికమ్స్ మైనస్ బికాస్ నెగిటివ్. మైనస్ 1/2 ఓకే ఇంటూ 100k. ఏం కవిత? కవిత మేడం జాగ్రత్తగా చేయండి. ఎస్ వెరీ గుడ్. మినిమమ్ ఈజ్ 950K. 950K. అర్థమైందా? ఇలా చేయాలన్న ప్రాబ్లం. ఓకే, ఇప్పుడు లాస్ట్ ప్రాబ్లం ఇవాళ క్లాస్లో. ఇవాళతోని మనకి అన్నీ కంప్లీట్ అయిపోతాయి. రేపటి నుంచి మనము వీఆర్ ఎంటరింగ్ ఇన్ టు ద వెరీ వెరీ ఇంపార్టెంట్. వాసు వెరీ గుడ్, కవిత వెరీ గుడ్, శ్రీనివాస్ వెరీ గుడ్. రేపటి నుంచి రేడియో రిసీవర్స్ నారా చాలా చాలా ఇంపార్టెంట్ టాపిక్ వెళ్తాం. ఓకే, ఐఎమ్ క్లోజింగ్ ద టుడేస్ విత్ లాస్ట్ ప్రాబ్లం. ఓకే, హీ హాస్ గివెన్ ఏ సిగ్నల్. ఓకే, ఒక సిగ్నల్ ఇచ్చాడు. ఇది కామన్ డేటా క్వశ్చన్. అంటే m(t) ఈజ్ ఏ పీరియాడిక్ ట్రయాంగులర్ వేవ్. ఓకే, వాడు ఒక పీరియాడిక్ ట్రయాంగులర్ వేవ్ ఇచ్చాడు. ఇలా ఉంది నాన్నది. ఇలా ఇచ్చాడు ఒక ట్రయాంగులర్ వేవ్. ఓకే, నా ఈ యొక్క ట్రయాంగులర్ వేవ్లో ఓకే హీ హాస్ గివెన్ ద సర్టన్ పారామీటర్స్ ఓవర్ హియర్. ఓకే, ఇది కంప్లీట్ ఒక వేవ్. ఈ కంప్లీట్ వేవ్ కాబట్టి ఇది ఒక వేవ్కి T0. ఓకే, ఇది అప్పుడు ఏమైతుంది T0/4. ఓకే, ఇది T0/2. ఓకే, ఇది ఏమైంది 3T0. ఇది అనమాట. ఇది కంప్లీట్ ఒకటి ఏమైతుంది, దిస్ కంప్లీట్ వన్ ఈజ్ హౌ మచ్. ఈ కంప్లీట్ని T0 అనుకుంటే వేవ్ అప్ టు హియర్. అప్పుడు ఇది ఏమవుతుంది, దిస్ ఈజ్ హాఫ్. ఇక్కడ ఇది ఏమైంది T0/2. ఓకే, నా ఈ పారామీటర్స్ ఇచ్చాను అన్న మీకు. సో వాడు ఇచ్చాడు వాల్యూస్. ఓకే, m(t) ఎంత ఇచ్చాడు, m(t) మ్యాక్సిమం వాల్యూ మ్యాక్సిమము 1 ఇచ్చాడు, వాడే ఇచ్చాడు. అండ్ m(t) మినిమము వాడే ఇచ్చాడు, -1 ఇచ్చాడు మై డియర్ స్టూడెంట్స్. ఓకే, అండ్ క్యారియర్ ఫ్రీక్వెన్సీ FC ఈక్వల్ టు 100 kHz ఇచ్చాడు. ఈజ్ దట్ క్లియర్? వాడే ఇచ్చాడు. అండ్ విత్ టైం పీరియడ్ ఇచ్చాడు. ఎంత? ద టైం పీరియడ్ ఈజ్ 10⁻³ seconds. వాడే ఇచ్చాడు అన్న. ఓకే, టైం పీరియడ్, కంప్లీట్ టైం పీరియడ్. దిస్ ఈజ్ అప్ టు హియర్ టు హియర్. దిస్ వన్ ఈజ్ హౌ మచ్ 10⁻³ seconds. వాడే ఇచ్చాడు అన్న. దిస్ ఈజ్ 1 ఇచ్చాడు వాడే. ఓకే, అండ్ హీ హాస్ గివెన్ దిస్ పర్టికులర్ వన్. ద వాల్యూ కరస్పాండింగ్ ఈజ్ దిస్ వన్ ఈజ్ -1. ఓకే, అప్పుడు ఇది ఏమైతుంది, ఇక్కడ కదా T0/2, ఇదేమైతుంది T0/4 కదా. T0/4 which is equal to nothing but here 0.25 into, it is in milliseconds. Sorry, here this will be given T0 in 10⁻³ okay, here is 0.25 into 10⁻³ okay, you need to convert. Okay, into this is x. Next, this is 1. You are getting my point? Similarly, this is 0, 0. I am writing the coordinates first. Okay, and here now again he has given here this is T0/2. Okay, this is again 3 times. Okay, so 3T0/4. This is what 3T0/4. Then it becomes again T0. Okay, so this value is how much? 0.75 into 10⁻³ comma -1. Okay, this is also, this is the value 0.75 my dear students. ఇవన్నీ ఇచ్చాడు వాడు. ఈజ్ దట్ క్లియర్? సో ఈజ్ దట్ క్లియర్? 0.75 into this one. ఓకే, సో ఈ పారామీటర్స్ మొత్తం ఇచ్చి ఫస్ట్ ఒక్కొక్కటి అడుగుతున్నాడు వాడు. ఏంటంటే ద మ్యాక్సిమం అండ్ మినిమం వాల్యూస్ ఆఫ్ ద ఇన్స్టాంటేనియస్ ఫ్రీక్వెన్సీ ఫర్ FM. Maximum and minimum instantaneous frequency for FM. He is asking the maximum minimum. He has given the KF value is how much? KF equal to 10 kHz/volt. వాడే ఇచ్చాడు. అర్థమైందా? Therefore maximum, so Fi of max. తర్వాత మనము ఫేజ్ కనుక్కుందాం. ఫస్ట్ ఫ్రీక్వెన్సీ కనుక్కుందాం. Fi equal to FC plus KF into m(t) of max. What is the value? ఎంత నానా, ఎంత వస్తుంది? దిస్ ఈజ్ 100K plus Kf is 10. How much it is? This is 10 into 10 cube into 1 volt. This is maximum is this one. What is the value? ఎంత వస్తుందారా? How much you are getting? How much you are getting, my dear students? How much it is? 100. This is what? 10. ఎంత వస్తుందన్న అప్పుడు? You are getting 110 kilohertz. Next, Fi min. FM లో equal to, very good. Okay, very good. Thank you. Fi min equal to Fc. Okay, Fc. Again, my dear students, minus Kf into m of t of min. Okay, this is minimum value. Yes, my dear students. So the minimum value we have to substitute Fi, and this is the minimum value you need to substitute. So it becomes yes 110. Another is 100k minus, because negative value, 10 into 10 power 3 into 1 volt. You are getting this value is 90. Very good. 90k. You are getting the minimum value. ఇది అర్థమైంది కదా? సిమిలర్లీ మీరు స్లోప్స్ ఫేజ్ మాడ్యులేటెడ్లో వీటికి స్లోప్, దీనికి స్లోప్ ఫైండ్ అవుట్ చేస్తే ఫేజ్కి, నెక్స్ట్ మై డియర్ స్టూడెంట్స్ దీనికి స్లోప్ ఫైండ్ అవుట్ చేస్తే మీకు ఇది 4000 వస్తుంది అన్న స్లోప్ ఫేజ్కి. సిమిలర్లీ ఈ రెండుకి మీరు స్లోప్ కనుక్కోండి. యు ఆర్ గెటింగ్ దిస్ వన్ ఈస్ -4000 వస్తుంది. అర్థమైందా? -4000 వస్తుంది అన్న స్టూడెంట్స్. ఓకే, దట్ ఐఎమ్ రైటింగ్. ఓకే, వెరీ గుడ్ ఎవ్రీవన్. నవ్ ఐఎమ్ రైటింగ్ ఇన్ ద నెక్స్ట్ పేజ్. నవ్ ఐఎమ్ గోయింగ్ ఫర్ ద PM, ఫేజ్ మ్యాక్సిమం అండ్ మినిమం ఇన్స్టంటేనియస్ ఫ్రీక్వెన్సీస్. ఓకే, ఎలా ఉంటుంది అది? ఇలా ఉంటుంది. సో యూఆర్ కన్వర్టింగ్ ఫేజ్కి వచ్చేసరికి అప్పుడు ఇది ఎంత అవుతుందన్నా? దిస్ ఈజ్ నథింగ్ బట్, మీకు ఎంత వస్తుంది చెప్పాక స్లోప్స్ మీరు ఫైండ్ అవుట్ చేయండి. ఫైండ్ అవుట్ చేస్తే మీకు ఇది ఎంత వస్తుంది? ఇది 4000 వస్తుంది, ఇది -4000 వస్తుంది అన్న. ఓకే, దిస్ ఈజ్ వెరీ గుడ్. దెన్ Fi equal to, that is Fi max. If I am going for the Fi max, Fi max equal to, my dear students, Fc plus Kp by 2 pi into d by dt of m of t of max. That is Fc is 100k. Okay, Kp value how much he has given? Kp ఎంత ఇచ్చాడనా? Kp is pi. వాడే ఇచ్చాడు, pi radian per volt అని ఇచ్చాడు. Okay, very good. That is how much you are getting? So it is 1/2 into 4k. అప్పుడు ఎంత వస్తుంది అనేది? 102 kilohertz. నెక్స్ట్ Fi min చేయండి. Fi min చేస్తే Fc. ఓకే, అగైన్ మినిమం ప్లస్ Kp by 2 pi into d by dt of m of t of minimum. Therefore Fi min equal to 100k minus, this is -4000, that is 1/2 into 4k. You are getting this is 98k, my dear students. Very good. With that we have finished the subject of complete, my dear students, the analog communications. Okay, రేపు ఫ్రెష్గా వీఆర్ ఎంటరింగ్ ఇన్ టు ద రేడియో రిసీవర్స్. ఓకే, ఇన్ని ప్రాబ్లమ్స్ మీకు ఎవరు చేయించారు నానా? నేనే చేపిస్తున్నాను. వెరీ ఇంపార్టెంట్, మై డియర్ స్టూడెంట్స్. యూ కెన్ గో ఫర్ ద ఈచ్ అండ్ ఎవ్రీ ప్రాబ్లమ్ ఇన్ ఎ డీటెయిల్ మేనర్. We have finished all the analog communications as far as AM and FM is concerned regarding the problem solving and the concept. Okay, now మీ ఇవి దాటి మీకు ఓకే ఎక్కడికి బోర్నానా? ఓకే, ఇక్కడతోనే మీకు ఓకే మ్యాక్సిమం నా కమ్యూనికేషన్స్ నోట్స్ ఇంతవరకు మీకు ఏ గేట్ ప్రాబ్లం అయినా ముందు దీని మించి బయటికి పోదు. కవిత, శ్రీనివాసరావు, వాసు చాలా నీట్గా నేను తయారు చేసిన నోట్స్ ఇది అండ్ గోయింగ్ టు గివ్ ద ఈచ్ అండ్ ఎవ్రీథింగ్ ఇన్ ఎ డీటెయిల్ మేనర్. Okay, you please once again go these recordings and share these recordings to your friends so that they also will be utilized in effective manner. ఓకే, రేపటి క్లాస్లో మనము డీటెయిల్డ్గా మనము రేడియో రిసీవర్ స్టార్ట్ చేస్తాం. చాలా చాలా ఇంపార్టెంట్, చాలా నీట్గా రేడియో రిసీవర్స్ తర్వాత డిజిటల్ కమ్యూనికేషన్స్కి ఎంటర్ అవుతాం మనం. ఓకే, చాలా నీట్గా చదువుకుందాం. ఓకే, థ్యాంక్ యూ వెరీ మచ్ వన్స్ అగైన్. హోప్ యూ ఎంజాయ్డ్ ద సెషన్ మై డియర్ స్టూడెంట్స్. థ్యాంక్ యూ వెరీ మచ్. థ్యాంక్ యూ వన్స్ అగైన్. Now as far as the Unacademy is concerned, the number of Facebook, okay, aspirants and the number of aspirants are day by day increasing, my dear students. And you have the Unacademy Telugu channel is there where you can access the subject, my dear students, in a detailed manner. Next, see the various Unacademy channels are there. You can study the subjects in different streams also. And finally, thank you very much, my dear students.